Hello,
Hello.
everyone. Welcome to Feedstuffs 365. I'm Sarah Muirhead. Our topic for today's session is biogas technology. And to walk us through the nuances of biogas technology is Patrick Serfass. He is Executive Director of the American Biogas Council, which is the leading trade association representing this industry. Welcome, Patrick. Thank you so much for joining us here today.
Thanks, glad to be here.
So let's start the conversation by making sure that we're all on the same page when it comes to defining what biogas, what the technology, what the system is. So tell us in very general terms, what does a typical system, how does it work and what does it look like?
Well, in nature, if you leave a pile of food waste or manure or any kind of organic material just in a pile, in the middle of that pile, no oxygen gets to it. And the microbes that are already present in that material, they replicate and they eat up the organic material and they burp out methane. So that's been going on since the beginning of time in the universe. And what biogas systems do is they take that natural microbial process and they just optimize it. So you put all the organic waste, like food waste or manure or wastewater sludge, you put it in a tank. You heat it up to about body temperature, so like 100 degrees, and that is the right temperature for the microbes to multiply. And the more microbes there are, the more you have eating up the organic material. They burp out the methane, but which it's captured in this airtight tank. In the roof of the tank, the gas is captured, and you can use that for energy. And in the meantime, all that organic material that was eaten up by the microbes, that becomes like a super fertilizer, and all the nitrogen and phosphorus and good nutrients in the material originally is still there in the digested material. So you get an energy benefit and you get a great soil amendment.
So it sounds like one of the main benefits then is that whole recycling of material into renewable energy and soil products. But besides displacing fossil fuels, which I'm assuming that biogas technology does, are there some additional environmental benefits associated with the technology?
Yeah, so a lot of the discussion is often around energy because that's where most biogas system owners make their money selling the biogas as energy. But that overlooks the large number of benefits that also come along with it. And really, recycling material is at the heart of the system. So we are recycling material that might not otherwise be recycled. We're reducing odors. We are displacing synthetic fertilizers with natural fertilizers, which also reduces fossil fuels. And we're creating like a community super system that both produces renewable energy, recycles material, and does it in a way that you're returning the material to the natural cycle of things. It's kind of the way it should be.
So is biogas a direct replacement, would you say, for non-renewable fossil fuels? Is it a kind of a one-to-one replacement, or what does that look like?
Yeah, so in biogas, you have methane, and methane is where your energy is. And once you have that, you can turn it into electricity using an engine or a fuel cell or a microturbine. So you can directly replace electricity from any source with biogas electricity. You can also, when you take the biogas and you remove the carbon dioxide that's in it, so you have pure methane, that's basically the same as conventional natural gas. And now you can put that into our natural gas pipeline system and replace it one-to-one with conventional gas. And now you're decarbonizing our gas system and putting renewable gas that wouldn't otherwise be there. And then you can use it any of the way that natural gas can be used. So you can put it in vehicles. You can use it to replace diesel vehicles. And then you can also even make things like plastic. Like Dell Computers has actually shipped a bunch of their computers in plastic bags made from biogas, from renewable natural gas. So there's lots of cool things you can do with it.
Oh, that's very neat. What about the economic benefits? Of course, we got to get down to that, right? We got to talk what it means, and let's, if we can, put it to say a large livestock operation. What would be the ROI for a large dairy or other type operation?
Yeah, so I'll give you the answer for kind of most size operations. So we've got about 317 biogas systems that are operating on farms around the country, and they range in size from farms that have 100 dairy cows. I'll just use the dairy example as one, about 100 dairy cows to like 10 to 15,000. So it goes from very small to kind of super XXL size farms. And the trick with the economics is just to make sure that you are saving enough money for summer operations of the farm and making enough revenue. So on the revenue, you're usually selling the biogas as some form of energy, and you get paid for that. If you can sell the digested material, maybe outside the farm as a fertilizer product, some farms are doing that. You can make some money from that too. But then you're also saving money in some instances. So again, to use a farm example, especially a dairy example, dairy farms use bedding for their animals. Happy cows make more milk, and happy cows are comfortable cows. So that bedding material is really important. And you can take the fiber out of the digested material, which when you dry it is really just looks like sawdust, which is a common bedding material. So you can replace the sawdust or maybe the sand bedding at a dairy with the digested material. So you're saving money there. And then, of course, all the nutrients that are in your digested material, you can use that to apply the right ratio and volume of nutrients to your field. And that allows you to spend less money on synthetic fertilizers, which also can help with reducing water pollution and things like that, reducing nutrient runoff. So there's a lot of, it's a whole kind of closed loop system. And even to take it one step further, dairies have to deliver their milk every day, and usually they're delivering it close by. And so we even have instances where the milk that might be going to making cheese or yogurt, well, that food processor also has a waste product. Usually it's like a high strength wastewater or like a whey wastewater. Well, that water can then come back, that wastewater can come back to the farm as an additional feedstock to make more biogas and recycle that material there. And then again, help put more nutrients in the field to grow more crops, which the animals eat, and then their manure makes the biogas, and you get this wonderful closed loop system, this full recycling system when it's done right.
I was at a dairy many years ago, and I believe they were using the byproduct to make little pots for plants. They were having it shipped off and made into these pots that would decompose, over time. So that was pretty cool. I don't know if they're still doing it or not, but that was pretty neat to see. So when we talk about, say, a dairy or a livestock operation, is there a certain size where it makes sense, or that really doesn't matter? You mentioned, you've got 300 plus that you're working with, and 100 sounds like 100 is your kind of your smallest dairy. But is there an economic benefit to being, say, a larger system, or does it really even matter?
Well, of course, the economics of your system really matter. But what can really change things is whether you're taking in any additional waste streams onto the farm. So usually if you're talking about a farm-based system, your main waste stream is your manure. But it could also be the waste from any animal processing facility. And one of the important things to think about with manure is really food waste that's already been digested once by the animal, right? So it has a little bit less energy in it compared to food waste or an animal processing waste, or like wash water from or maybe the blood from animals or paunch or things like that. All of that material has not been digested yet, so it has a lot more energy. In fact, those waste streams can have 10 to 30 times more biogas potential in them than manure. So when you talk about the size of a system, it really matters significantly whether you're taking in outside waste streams and adding outside waste streams into the farm. So if you're just doing a manure-based system, we would say 500 head and above is a general rule of thumb for what makes a biogas system economical. But then you start adding food waste into the picture, and not only can you improve the economics for the large farms, but now you can make small and medium-sized farms work really well. And then it also depends on how you're selling the biogas. So if you're selling the biogas as renewable natural gas, those, which basically means the pipeline equivalent gas, you have to process the gas a little bit. Those systems to process the gas are more expensive than electricity generating systems. And so they work better on your larger system. So either lots of food waste coming in or lots of manure or both. And then if you're making you're turning your biogas into electricity, then that generally can work better on your smaller and medium-sized farms because that equipment can scale down cost-wise a lot better. So when you talk about the size of the system, it does matter about a few of the variables do matter, but the biggest ones are you taking in any additional waste besides manure, and how are you using the biogas? And that's really what allows the biogas system to work on most size farms, which is a good thing because we need more of them.
Well, then it really depends on where that say food waste or whatever else you might want to try and incorporate, how far that is from your from your system or from that system you're working with, because of course there's that cost of transportation and all of that that would be involved as well for that. So if I'm a producer and I want to consider adding, say, a digester to my operation, or choosing to work with a partner, a local partner, a biogas partner, what would I look for? What are the questions that I should ask?
Well, I think the first thing to do is just start talking with some developers. And so, the American Biogas Council is full of companies that want to work with farmers to help you figure that out. But you're basically going to do a feasibility study. You're going to look at, okay, how much manure do you have and how is it being collected? For example, manure that's out in the field where when you collect it, it's kind of hard to collect, or maybe it's getting collected with dirt and other things in it. That's not as attractive as manure that's being scraped out of a barn and therefore is less contaminated with other things that can be really abrasive to the system. So you want to know how much manure you have, how it's being collected, is it contaminated? You also want to know what types of outside farm feedstocks you might be able to add. And then you want to look at the products that are really needed. Are you, as a farmer, primarily motivated by being able to replace the electricity and the heat that you use on site? Or are you interested in selling your energy offsite, which can be more complex, but can also be a lot more lucrative? Selling it to fuel vehicles, for example, somewhere else, or helping a large corporation that's trying to reduce their carbon footprint, selling carbon credits and the gas to someone else off-site that might pay a premium for having access to really low carbon renewable natural gas or renewable biogas. So I think starting with those basics is the main thing. Talking with the developer is the easiest way to just kind of ask some questions and start to figure it out. And then another big question is, are you the farmer who wants to do everything yourself and own and operate the system? Or do you really want a turnkey solution where you want someone else to come in and handle it for you? And there's all kinds of options that are out there, but that's a very personal decision that everyone needs to make. And it really depends, therefore, on which kinds of companies you want to work with. Because some of the companies out there just want to do turnkey systems. They say, hey, I've got my way of doing it. It's been working really well for a long time. I'm going to do this. That's what I do. And then others will license the technology and the farmer can build it. The tank for biogas systems, can sometimes be as simple as pouring concrete like a pool. It could be like an in-ground pool. And most farmers know how to do that kind of stuff. Most farmers know how to build, put the piping in and even do the electrical systems and things like that. But even if you can do it, you may not want to. So choosing how involved you want to be in the system is also kind of a fundamental question for each person to answer personally.
Have you at the Biogas Council, or maybe someone else has, put together any kind of numbers to really look at, what the industry provides in, say, a year's time, maybe in kilowatt hours, or some other kind of measurement, and even what this might mean from, say, an emissions reduction standpoint?
Yeah, so I would say that by and large, we've really only scratched the surface for the potential of the industry. I'd say we're at somewhere, depending upon how you count it, like 1 to 10% of the potential for the entire industry. So things are really just beginning in the U.S. for biogas. The industry, by contrast, in Europe is a lot more mature. They're kind of about maybe 10 to 15 years ahead of where the U.S. is. So there's a lot of potential here. Today in the US, we have 2,300 operational biogas systems. So of those 2,300, I mentioned 300 of them are on farm. The large majority of them are actually at municipal wastewater facilities. Then we have a lot of standalone food waste systems. And we'll count some landfills in there that are doing good things. So 2,300 operational biogas systems, but the opportunity to build at least 15,000 new systems. Right now, for the electricity generating systems, we're generating about enough electricity to power 1 million homes, but that could easily be well over 10 million homes with more systems built. For the systems that are making vehicle fuel, right now they're fueling the equivalent of about 1.2 million cars, but the potential to fuel more like 30 to 40 million cars. And in terms of the greenhouse gas reduction potential, even the worst performing systems are reducing greenhouse gases by 50% compared to gasoline or diesel vehicles. And the best performing systems are reducing carbon emissions so much it's like removing it's like removing 6 times as many vehicles off the road as a gasoline or diesel vehicle. And the reason for that is they're carbon negative projects, because what you often can do on a farm is, if the farm is connecting its manure in an open manure lagoon, that's putting methane emissions into the atmosphere. That's a common practice in the US today. But if you take that manure and you recycle it in a biogas system and you're capturing all that methane before you've even used the biogas, you're having a massive greenhouse gas reduction impact by just capturing the methane. And now when you use the methane, you use the biogas to displace fossil fuels, you're having an additional carbon reduction benefit. And when you add those two together, you can get deeply carbon negative projects, because you are reducing so many emissions that would otherwise be emitted, and you're displacing fossil fuels. And that means that biogas systems can reduce carbon, in a transportation scenario, 6 to 7 times more than wind or solar to battery electric vehicles. And I'm not saying that we shouldn't do wind or solar to battery electric vehicles. We need that too. But the point is that there's a massive potential for greenhouse gas reduction from biogas systems. And it's because we are recycling material that isn't already being recycled. And that recycling benefit is it's so key. No matter what position you have on energy, that waste isn't going away. Our number of animals are generally increasing, number of people are increasing, and the waste associated with the people and our animals has to be managed. And luckily, biogas systems are a great way to do that.
So what do you find? I mean, there's the great story there, but what do you find from a consumer perception standpoint around the technology? Is it something that consumers are fairly accepting of, or is there a little hesitancy?
Well, I'd say, unfortunately, the biggest response is no response, because most people don't even know about biogas. So that's why I'm really glad to be talking to you about this. So hopefully there's some folks listening who are learning something new. I would say that if you're not familiar with biogas, there can be a fear of the unknown, but just like there is for everything. I mean, there's some people who don't think that wind and solar are good, and don't understand that, or other renewable energy sources. But I can tell you, been around this industry for a long time, and I have never found anyone that's been to a biogas system that doesn't leave impressed at how awesomely it can do so many things at once. They're just impressive, and they're impressive because they are doing so much. We're recycling material, we're producing renewable energy, we're producing natural fertilizers, we're returning material to the natural cycle of things, which is really what taking care of our land and our air, water, and soil is all about. So, I think the key is to just tell these stories more and tell stories of successful biogas systems, because when you see it and you hear it, you can't help but be impressed, and it's because they're doing great things.
I visited a big installation that actually was taking place outside of Madison last fall, and if I recall, there was a lot of discussion in terms of what it takes from a state and local government standpoint, from a siting and permitting and all those fun things when it comes to these kinds of systems. Can you walk us through kind of how, not the process necessarily, but how difficult it might be to get a system in place?
Well, it all depends on whether or not the public officials that you're working with have done this before, right? So even though we've got biogas systems in all 50 states, lots of them, as I mentioned earlier, are wastewater facilities, and the number of them on farms is, relatively small, only 317 today. So it really depends when you're getting things permitted, whether you're working with someone who's done this before. Because otherwise, if they haven't done it before, you walk in and say, "Hey, I'd like to build a biogas system." They say, "Oh, is that a recycling system?" Or like, "Yeah, but probably not the kind of recycling facility that you're thinking of." And they say, "Oh, was it a landfill?" Like, "No, but I am handling waste." "Well, are you a farm?" "Well, it's on my farm, but it's not really farm mean." So, you might talk to someone, and they're trying to fit you into one of the other boxes that already exist. And what they really need to do is create a new box. So that can be a little bit challenging, but you should rely on the industry, rely on us, the American Biogas Council, and others to help with that education, and rely on your fellow farmers, the ones who have it. There are biogas systems in all states, so just getting in touch with people who've done this before can be a huge way to accelerate the process of getting a system built.
You mentioned that there's this took off. I think it was 10 or 15 years earlier in Europe than it did here in the U.S., and that there's a lot more systems there. Are those systems largely on farms, or is it other uses that you see when you look at the European situation?
You'll see a mix. You'll see a mix. And the reason of like on-farm and off-farm systems, part of the reason that things have been really accelerated there is because there's a lot less landfill space. So they're motivated to find other places to deal with their waste. And the agriculture industry is really different. It's not based on large farming as much as it is here in the U.S. And that creates a much more distributed infrastructure that where you need to take care of waste in like lots of different places. And they're also a lot more aggressive in promoting renewable energy and recycling than we are in the US. So all those things kind of come together and you've really accelerated the industry. Those changes are slowly happening here. I think what we need here in the US is really just a recognition of how much we need to recycle our organic material and the fact that that material is not going to manage itself. And the fact that farms provide a huge opportunity to help with that solution and in a way that where the farms just aren't doing the work to help out, they're benefiting from it as well. And I think the more that we can get our policymakers to understand the huge waste management opportunity that we have with farming, the more we'll be able to get this industry to accelerate. It actually is growing really quickly. We had our fastest growing year for the industry just last year. But there's always more growth that can happen. And like I said, we're at like 1 to 10% of the potential for the industry. So there's a huge amount of opportunity out there and number of systems that need to be built because there's a lot of organic material that is not being as managed as well as it could be.
So when you said you had a great year of growth last year, can you give us a number?
Yeah, so right now it just happens to be with the way the policies are currently in the US. There are some strong incentives to turn your biogas into renewable natural gas. That's the pipeline equivalent gas and use it to displace fossil fuels in our transportation sector. And that sector of the industry grew by 47% last year. So strong double-digit growth in just 1 year in 2021. And what was even more exciting than that is that while that double-digit growth happened for getting systems that were in construction to in operation, the number of systems that went into construction also increased by 42%. So you're not just seeing strong growth, you're seeing an acceleration of growth. And it's in some ways it's to be expected, right? More and more people are catching on, and the more that you see these systems operating well, the more it makes sense. The more people see like, gosh, yeah, we really should have these. Otherwise, what are we going to do with all this material? And I hope that continues. Things look good so far.
Well, and I think with all the situation on fossil fuels right now and trying to be more dependent, self-dependent on our energy sources, you're probably going to see even more acceleration in growth in this area. Would you agree with that?
Yeah, and you can use it everywhere because you have the potential to make biogas wherever there's organic material, and there's organic material wherever there's people and animals, and we have them everywhere. So there certainly are states that have more potential than others, basically where there are more people or animals. That's why some states like Wisconsin and New York and California and Texas are some of the biggest potential states. But the potential really is everywhere, and it's not just on farm, right? It's also standalone food waste systems. Those are the other kinds of systems that you see a lot of in Europe. Is just food waste recycling systems. It's also at your municipal wastewater facility. I know of some farms that switched to cheese making, but the municipal wastewater, the municipality didn't have a big enough wastewater facility to handle all of their wastewater from the cheese making. So the farm built a digester to be able to handle their waste, and then did a bunch of other things too. So they helped out the municipality. The municipality was even helped them to pay for the digester because otherwise there would have been a huge cost to the town to upgrade the wastewater facility to be able to handle growth in industry. So kind of a win-win there to be able to do that, and those opportunities will abound.
What are we looking at in terms from a policy standpoint? Are there some things that we need to maybe be looking at changing at the federal level or state level that would help to accelerate this technology?
Yeah, I think at the federal level, there are a lot of renewable energy industries that have benefited from tax credits for a long time. The oil and gas industry has benefited from them as well. So creating some parity The Build Back Better bill that the House passed and is stalled in the Senate right now actually has a number of renewable energy incentives in it that could be really helpful to farmers to be able to reduce the cost of their biogas system and also to reduce their tax liability. So to encourage more renewable energy and more recycling systems to be built. And then at the state level, there's the opportunity to pass clean fuel standards. These are policies that incentivize anyone that makes renewable fuel by saying, hey, the lower carbon you can make your renewable fuel, the more credits you can generate, and then those credits can generate additional revenue to help pay for the project. So it incentivizes a local growth of renewable fuel production in the state. There's a number of other things that can be done, like for example, right now a lot of places around the U.S. we have the option to buy renewable electricity instead of whatever the grid mix of electricity is. I know I buy 100% renewable electricity where I live here in Washington, D.C., but I don't have the option to buy 100% renewable gas. And that is slowly changing. We have about 3 or 4 states where if you live in those states, Vermont is one, you can choose to buy renewable gas instead of conventional gas. And getting those policies to change so that consumers can also make choices and they can choose to buy renewable energy will also be really helpful.
So as we wrap up here, where's the best place for a producer to go to get more information on the biogas, on the technology or the industry, or what those questions to ask and that kind of stuff?
Well, you're probably not surprised, but I'm going to tell you AmericanBiogasCouncil.com. So AmericanBiogasCouncil.com or .org, either one. Just click on benefits of biogas. It's right on the top there. That'll help you to get more familiar with it. We've got lots of companies you can use for resources. We've got tons of free stuff at the American Biogas Council website, and we're here to help you to learn and help you to develop projects. That's our reason for existing. So use us, and we're here to help.
Very good. Patrick Serfass, Executive Director of the American Biogas Council in Washington, D.C. Thank you so much for your time today and for your insight. For all of you tuning in, we thank you for being here as well. A reminder that you can view all of the Feedstuffs 365 programming anytime on feedstuffs365.com or from feedstuffs.com, and just click on the little logo for Feedstuffs 365 and you'll come right to this to our page. Also, don't forget to watch your email inbox for upcoming sessions. Until next time, for Feedstuffs 365, I'm Sarah Muirhead.